In this lesson, we will be talking about the transcriptional regulation mechanism known as positive repressible. This mechanism involves a protein that binds to the operator region of a DNA strand, allowing RNA polymerase to bind to the promoter and continue transcription of the structural genes. Because this protein stimulates the transcription process, this protein is called an activator, and the region in which it binds to is known as the activator DNA binding site. On its own, this protein promotes the transcription process. But in the presence of a small molecule known as an effector, the activator's protein shape is changed, and therefore it can no longer bind to the operator, which then means it cannot stimulate RNA polymerase to begin transcription. Therefore, transcription is inhibited or repressed. The positive aspect being that the activator on its own without the effector will promote transcription, whereas the repressible part of the system is the small effector molecule, which then can repress the function of the activator. To further explain the positive repressible mode of transcriptional regulation, I will employ the following analogy. To properly handle and flip a grilled sandwich with a spatula, you also need to use tongs. Flipping the sandwich represents transcription, and the spatula represents the RNA polymerase. Tongs on their own are able to grab onto the sandwich, which activates the flipping process. But when the sliding lock is bound to the tongs, the flipping of the sandwich cannot take place. In this scenario, the tongs on their own represent the activator protein that promotes transcription, aka flipping of the sandwich. The lock added to the tongs represents the small effector molecule because it changes the shape of the tongs so it can no longer bind to the sandwich, which would then inhibit the binding of RNA polymerase, which would then inhibit transcription.